Hello guys, this is Scienceman and today we are going to learn about meter. What is meter? Its definition throughout history, right? Okay, so actually from ancient times there were already many units, right? Many units. They used to measure use those units to measure quantities, right? So at that time, ancient time, many countries used many different units. So you can understand if every country use different units, the number of units will be very large. So in ancient times there were almost 1,50,000 units, right? So this was very problematic. This turned out to be very problematic when international trades were taking place, right? Why? Because if guess A country and B country, when B is selling something to A, if A use a different unit system compared to B, then there will be problem, many kind of problem, and for that reason also cheating happens in trade. So that's why France in 1790 France decided that the whole world needs to come to an agreement of a standard unit system, right, which will be accepted throughout the globe. Everyone will use that standard system. So what they did in 1790, France approached Britain and America. France reached out to Britain and America and proposed that all three of them work together and come to a conclusion of a standard unit system that will be distributed throughout the globe, which can be accepted, right? So for at that time there were many political reasons, many wars going on at that time. So for that reason America and Britain did not accept the agreement. So this proposal was cancelled. But France did not give up. France actually started working on the standard system on their own, right? So in 1795, France already started working on the decimal metric system. Okay, so experimentation was going on. In 1832, a German physicist named Carl Gauss invented the CGS system, right? The first invention of CGS system. But at that time, according to the CGS system, what is the units? Length is centimeter, mass is gram, and time is second. But when Carl Gauss first invented that system, then he assigned milligram in place of mass, millimeter in place of length. So mass was assigned milligram and length was assigned millimeter, and time was assigned second. I know what you guys are thinking now. You must be thinking that the units centimeter, millimeter that we use now, millimeter and milligram that we use now is the same units as mentioned here, but when CGS system was first introduced, these units did not these units did not have the same definition as we used to have now. So what we have now, the millimeter, milligram, centimeter, all are derived from meter, right? But these first units, milligram, millimeter, in the first invention of CGS unit, these were defined differently. These were defined differently at that time. Similarly, what happened was, these units were very small, right? These units were very small, so in case of measuring large distances, these units became redundant. So what happened? Another reinvention happened in CGS system, right? Another reinvention happened. What kind of reinvention? Maxwell and Kelvin reinvented the CGS again. What they did was assigned gram to mass, centimeter to length, right? Maxwell and Kelvin assigned gram to mass, centimeter to length, and second in time. Okay, but same problem. These units here, gram and centimeter, does not have the same definition what we have now. Now the units of centimeter and gram that we use are derived from meter, right? So at this point meter was still not invented. So these had very different definitions, and those measuring systems were very faulty. Another problem arises. These units, centimeter and gram, also turned out to be small in case of larger lengths. Like if you want to measure a length of a road connecting two cities, then if you use centimeter, then it will have a huge numerical value which can turn out to be a very big problem in case of numerical problems. So this became also a problem, right? So now another definition came in place. The French physicist and scientist tried to define a new measuring system with the help of a pendulum. So they thought actually that as these measuring systems were turned out to be very small, they decided that they need a larger measuring system, larger measuring unit, from which other smaller unit can be derived, and they named it meter. Okay, so this was the start of the invention of meter. But at first the scientists and physicists thought that this meter can be defined with the help of a pendulum. Like how? This is a pendulum, right? So let's think that the pendulum has been given a force from this direction. So it is going back and forth. So we know that from this place to position A, and from position A to position B, and again from B to this place, this total time taken to move from O position, 0 position to A position, again A from B, again B to initial position is time period. So they defined this time period as 1 second. They defined this time period as 1 second and said if the exact pendulum they are using, if the period of the exact pendulum they are using is giving them 1 second of time period, then the length of this string from this position to the bob is 1 meter. Sounds like a good definition, but another problem arose. What problem? In approximately 1563, I think, Galileo already came up with the equation of time period, right? So the equation of time period was T is equals to 2 pi root over L by G. So if you look closely, G, when the height of the terrain of our earth changes, like you are in plane, the value of G you measure there will be different compared to the value of G when you measure the value of G on the mountain, right? So it fluctuates very minutely, but there is a difference. G value changes, right? We all know that G value changes even minutely, even a minute amount in the for the change of the height of the terrain from plain to mountain. The value of G changes. So if the value of G changes, then value of time period also will change, like, right? So if they are basing the definition of 1 second with time period, then it will be faulty, because time period is not a constant value, it can change, right? Plain to mountain it can change. So people living in mountain will have a different value of second, right? So this procedure turned out to be also faulty, right? So the scientists decided that this method cannot be used. So what they did after that, that they thought that they have to use a procedure to measure 1 meter, so that there is no dependency on second. They thought that they will use a procedure that does not require the second to be defined, right? So what would be the procedure? The procedure would be, they thought that they will take the help of earth. Okay. So what they did, suppose this is earth, suppose this is earth, right? So what they said is that they will measure 1/4 of the length of earth's circumference, right? So 1/4 of the distance of earth's circumference would be from north pole to equator, this distance, right? Total circumference is this. If we do 1/4, then what will be the distance from north pole to equator? Why did they take north pole to equator? Because that portion is land. Measuring something on land is easier than measuring something on sea level, right? So they choose from north pole to equator. But you guys must be thinking that how is it possible to measure this huge distance. You can't get a measuring tape and measure from North Pole to equator, it's not possible. So what they did? What they did was they took the help of trigonometry. Though it will be a very in-depth description, but I will give it to you. In trigonometry there is a formula called sine formula of triangles. So that formula is sine formula of triangles. So according to this formula, if a triangle, three angles of a triangle is small a, small b, small c, and three sides are capital A, capital B and capital C, then sine A by small a is equals to sine B by small b, sorry, my mistake. According to this formula, sine small a by capital A is equals to sine small b by capital B is equals to sine small c by capital C. Okay, so they thought that they will measure a small distance from between two cities. So they choose from Dunkirk to Barcelona. So suppose this is Dunkirk and this is Barcelona, right? So they would measure this small distance, right? So what they did, they draw an equilateral triangle making this its base. So they know the three angles 60 degree. So if they know this two distance, this distance will easily be known, some distance. Now what they did, they added similar triangles adjacent to each other, imaginary triangles, right, and calculated how many triangles would it take to make this strip from North Pole to equator, and then measured, added the whole bases, then added the value of the bases, and they got the distance between North Pole to equator. Now another thing comes. Now we have measured the distance of North Pole to equator. Now what to do? Now they said that they will divide the distance between North Pole to equator, meaning 1/4 of the distance of Earth's circumference. They will divide this distance in 10 million parts, right, or 1 crore parts. They will divide this distance in equal 10 million parts. 10 million parts, equal 10 million parts. After dividing that distance into 10 million equal parts, each small distance will be called 1 meter, right? So if you take out one small distance after dividing it with 10 million parts, so this small distance will be 1 meter. Now they got the value of actual measuring system of SI 1 meter, right? So it was a success. So now the scientists thought that how other countries will measure the distance. They have to be supplied with some prototype. So what they did was they measured this meter and formulated an alloy, a platinum. They measured this meter and made a platinum iridium alloy 90:10. Platinum 90%, 10% iridium, right, of the same measurement. They made this alloy strip having same measurement and kept it in absolute zero temperature under 1 atmospheric pressure. Why? So that with the change of atmospheric temperature, the length of the alloy should not change. It should be constant. That's why they kept this alloy in absolute zero temperature under 1 atmosphere pressure in a chamber. It is kept like this till now. So after making this metal alloy, what they did, they measured that alloy and created many replicas, right, created many replicas and distributed it in almost all the countries, so that those countries can make their own prototype and same measuring system will be used. That's how meter was created. Now we have the definition of meter. Now actual meter was invented. So this is the actual meter of SI system. Now in CGS system, the centimeter we use is actually derived from this meter. This centimeter is very different from the ancient centimeter that Gauss invented, right? So after this the scientist thought that now as we have the actual measurement of meter, we can define it in a very easy way and in a very universal way. Universal way means universal way means defining meter with some other parameter that is completely constant, right. You guys will understand after I give the example. So what they did, they have the measurement. So what they did, they excited a krypton 86 crystal. So when you excite a krypton 86 crystal, it gives out a wavelength, a light of a particular wavelength. The wavelength does not change, the wavelength is constant. If you excite the krypton 86 crystal, it gives out a light that has a constant wavelength. That's why it is used. So after exciting the krypton 86, that light is emitted. Now this wavelength is compared with a 1 meter scale. Right. So they actually measured how many wavelengths will it take to complete 1 meter distance. So it was seen that in every case, whenever they were exciting the krypton 86, in every case there was a constant number of wavelength which is equaling the 1 meter of distance. What is the number? The number is 1650763.73 wavelengths. So another definition was formed with the help of krypton 86 isotope. According to this definition, 1650763.73 number of wavelengths of a excited krypton 86 crystal is 1 meter. I hope it's clear now. There is another definition, that is the main definition which is used now. Now another better definition we use. What is the definition? That definition is achieved with the help of the speed of light. So after all these, the definition of second was also achieved. I will cover that topic in the next video, the definition of second, right? So before that, we just need to know that after second was defined, it was very easy for other inventions like the speed of light. So after getting the speed of light, it was very easy for us to define the definition of meter. So we know that speed of light is 2.99 into 10 to the power 8 meter per second, but this is not the actual value. The actual value is 2.99792.456 into 10 to the power 8 meter per second. Sorry, it's 458. So this means that 299,792,458 1 2 3 4 5 6 7 8 8 299,792,458 meter distance is covered by light in 1 second, right? So 1 meter distance is covered by light is 1 by 299,792,458 second. This is the actual definition which is used now. So what will be the definition? The definition will be the distance covered by light in 1 by 299,792,458 second is 1 meter. This is the best and current definition that is used by the scientists and physicists. So I hope all the doubts are cleared. If there is any doubt, you can ask me in the comment section. In the next video, I will talk about the definition of second with historical facts, right? How second was achieved. So thank you guys. This is for now today.